Good morning, one and all. Gathered here for the nice webinar organized by EDOT Technologies, Palayam Kottai. Before I start, I pray to Almighty for blessing us with the wonderful opportunities to share our knowledge, even in the time of pandemic. All of us don't have equal talent, but all of us have an equal opportunity to develop our talent. These are the words of Dr. APJ Abdul Kalam. Such an equal opportunity has been gifted us by our Managing Director, Mr. Babu Shankar Ganesh, to develop our talent. EDA Technologies have been working as technical training company in Tirunelveli since 1994. It is one of the top-notch industrial service provider in various fields like embedded and software development. EDA Technologies has been offering the technical support for the complex industrial challenges, and also we offers embedded based products for the welfare of the technicians by ensuring all aspects of our custom embedded and software solutions. EDOTS exceeds expectation and kindled technical aspirants to deliver innovative ideas in software development projects and deliver valuable services that can accelerate the growth of industrial sectors. The main objective is to provide our customers with the latest technologies to improve their operational productivity. Quality is not just a word, but the oxygen of EDOT. This is the proud moment for me to convey my gratitude and also congratulate Mr. Babu Shankar Ganesh, the Managing Director of EDOT Technologies, who has made EDOT to reach zenith and also crossing a silver jubilee celebration. Babu sir, your dedication and creativity is the only key factor with an unquenchable thirst for success. In a nutshell, EDOT stands for exemplary. From a small seed, a mighty tree may grow. One such example for this is EDOT Technologies. Mr. Babu Shankar Ganesh, who has also an experience of 6 years in the instrumentation field in chemical plant at Spik Nagar, Thuthukudi, and also conducts embedded PLC, power system, power electronics, digital image signal processing and VLSI based classes and workshops in various engineering and polytechnic colleges around Tirunelveli, Thuthukudi, Virudhunagar and Nagarkoil. Once again, our compliment and greetings to you, sir, for commendable achievements. The most awaited session begins. Sir, we are ready to fill our hearts with your overflowing thoughts technologically. I hang over my session, sir. Thank you. Good
Good evening to everybody. I am Babu Shankar from EDOT Technology. Now we start Industrial Automation PLC webinar. The PLC most important in industry for automation purpose. So we discuss about its automatic industrial PLC webinar. What is PLC? PLC is a digital computer designed for multiple input and output arrangement. That is, the digital computer is used for industry for the purpose of control the input and output control system like sensors from input and motor is outputs. The PLC work in variable environment, that is variable temperature range, and it operates in case of any electrical noise it will stand, and also in industries has more vibrations than resistance, but the PLC will stand more reliable operation of industrial purpose, so that in real-time operating system, that is real-time system, is most best use of automation field is PLC. So we discuss what is PLC then why the PLC used for industry, then how it programming. So, so programming of PLC is most important. So the program logic controller is an electronic apparatus which use program memory for the internal storage of instruction for implementing specific functions such as logic, sequencing, timing, counting, and arithmetic to control through digital or analog model for the various type of machines or process. What is logic? The logic is AND gate, OR gate, NOR gate, XOR gate. There is a logic function. Sequencing logic means the process operate in a sequential manner, like step-by-step operation. The PLC can push. Timing, the process operates in a particular time, so you can program in a time. So the timing is very important for operating PLC programming system. Counting is most useful for counting conveyor object counting like this. The analog models are also used for PLC for measure the analog value from the various type of sensors like temperature sensor, pressure sensor, flow sensor like this. So the programming logic controller sends the input from the machineries and control the output. What are the major component of common PLCs? In PLCs, as most common, we are discussing most common devices. So input module, power supply, processor, programming device, and output module. The power supply connected to processor and output module and input module. The program feed to processor, then depend upon the program, the processor operate. The sensors are connected directly to the input module interface system. The input module interfacing system connected the data to processor. The processor take a decision depend upon the program and give a decision to output module. The output module control the output elements like valve, motor, like this. So these are the major component of common PLC system, that is input module and output module. The input module connected from the sensor. The output module connected to output devices, motor, then valve, fans like this. Programming language of PLC. So what is the programming language of PLC? Most common language encountered in PLC programming are ladder logic. This is important and main programming language in PLCs. And also the functional flag diagram, sequential function chart, and Boolean mnemonics. It's also used for PLC programming system. Ladder logic. Most common language in PLCs is ladder logic. So it is suited to combinational logic. This ladder logic symbol represented by the elements, that means of contact. So we saw three type of important symbols. Two are input, one is output. First, make contact. The make contact normally open. Normally the make contact is open. So the symbol is like this. Break contact. Break contact means normally closed. When it energized, it open. So normally closed, when energized, it break. So it's called break contact. In make contact, it normally open. When energized, the contact is make, that is connected. So it's called make contact. Then relay coil. So relay coil, it output device. Output device means the relay coil is energized, then the motor is operate. So in ladder logic programming system, we used the most symbols are make contact, break contact, and relay coil. What are the leading brand of PLCs? Allen Bradley, Modicon, Texas, that is TI, then GE, General Electrical Company, then Esco's PLCs are Siemens, Lochner, Stowe, Telemecanic. So these are the leading brand of PLCs used for valves. The Allen Bradley, Siemens, then Cutler-Hammer, Texas Instruments are mostly used in India. Why the PLC used in industry and what are the applications of PLCs? Wherever automation is desired, the PLC is best suited to meet the task. That is, the PLC is the best choice for control the automatic process of automation. In industrial system, a few example of PLCs are used area: robot manufacturing and control system, car parking control. Car parking control means the lifting of car and also operate the motor, lifting motors. That area, the PLC is one of the controlling part of car parking control system. Train control, that is railway station system. In railway station system, the track changing unit, signaling system, safety system, the train driving system. Food processing. The food processing industry, like manufacturing of biscuits, that industry, the whole process, input to output, that is the food intake from the vehicle, that is intake from the ground, and process, that means heating and packing and output to quality section. So all section in food processing industry, the PLCs are used. Material handling. Material handling section. In material handling, that means of shipyards, industrial manufacturing system, the PLC programmings are used. Machine tools, lathe, milling machines, that machines also the PLCs are used. Conveyor system. In conveyor system, the industrial product move from one place to another place. We are using more conveyor, belt conveyor, chain conveyor, roller conveyor, like this. In thermal power plant, the coal handling system, that is the coal from the yard, transfer to thermal station. The conveyor is most important. That area, the PLCs are used to control the conveyor. In conveyor, the conveyor motor driving system, conveyor safety system, and conveyor automation. What is PLC input? Then what is PLC output? In PLC inputs are in our view, pictorial view, the push button is input. For demo purpose, we are explaining the input is push button. The output is motor and lamp. The motor operates by the PLC through the conductor. The conductor is energized. The motor is operated. The conductor relay coil operated by the PLC. The PLC get the information from the input like push button or sensor. So when the sensor input is activated, depend upon the PLC ladder diagram program, the diagram program operate the conductor and operate the motor or lamp. So the basic PLC interfacing modules: input, PLC, output. The input are sensors, push buttons. The outputs are motor, lamp, wire, like this. In discrete input, there is digital input is an input that is either on or off, is connected to PLC digital input. In on condition, refer to logic 1 or logic high. In the off condition, it refers as logic 0 or logic no. See, in the picture, the push button normally open. The second picture, that is the second symbol, normally closed push button. So first symbol is normally open push button. Second symbol is normally closed push button. Like normally open switch, normally closed switch. In ladder diagram, the symbol is normally open contact, normally closed contact. So, in this picture, push button is press, the open is converted into close. Normally close push button is energized. The NC is make NO. So the digital input, that is digital input, logic input, 0, 1, on, off, high, low. So 0 means off, low. 1, logic 1 means on, that is high. This condition is referred as normally open, normally close. When the switch is open, it consider off, 0, low. The switch is normally closed, it consider high, 1, like this. The PLC input module, the 24-volt DC input PLC module, the input is normally open, that is off logic, 0 logic. The push button is normally open. When you press the switch, the logic is 1. The logic is 1. PLC input module get the input from the switch and it activated. In ladder diagram programming, NOT operation, it's very important one. In NOT operation, the figure shows A, C. Input A, output C. In the figure, it can be seen that if input A is 2, that is 1, the output C is 2, that is 0. Or when the input A is 0, output C is 1. In normally closed contact is closed, the output C is 0. When the A is 0, the output is 1. This is NOT operation. Normally in NOT operation, A is 0, output is 1. A is 1, output is 0. So this symbol refer NOT operation of ladder diagram programming. AND operation. In AND operation, A, B input, both are input. The C is output. In this ladder network, the ladder program refer a logic operation. Both input A, B is high, the output C is high. A is 0, B is 0, output 0. A is 1, B is 0, output is 0. A is 0, B is 1, output is 0. Both A and B is 1, C is 1. That is AND gate truth table. So depend upon the AND gate truth table, both A and B, that is both inputs are high, the output is high. So A is normally open, B is normally open, the C is 0. When A is make contact is closed, that is energized, B is also energized, then C is also closed, that is high. In OR operation, the input A and B is true, the output C is true. In this OR operation, A or B, A is 0, B is 1, the output is 1. A is 1, B is 1, output is also 1. A is 0, B is 1, the output is also 1. A and B is 0, the output is 0. That is OR gate truth table. So depend upon the OR gate truth table, A, B, both input are 0, output say is 0. Any one of A or B is 1, the C output is 1. This is OR operation. So in the figure, the A normally open contact, B normally open contact. When the A is energized, the output is energized, or the B is energized, the output C is also energized. So OR operation, we see the figure used for any one of input is high, the output is high. This is ladder diagram program for OR operation. The combination AND or OR logic operation. In this AND OR logic operation, AND gate, BB1, BB2, inputs A and B, like R1 is relay coil. In OR operation, BB1, BB2 is input A and B, and R1 is output. The combined AND OR operation, ladder diagram program. Combined AND OR ladder diagram program means if BB1 is high, R1 is high. BB2 is high, the R1 is low. BB2 and BB3 is high, the R1 is high. So BB2, BB3 is AND operation, BB1 and BB2, BB3 are AND operation. So OR and AND operation used this combined AND OR programming system. So the figure shows input model of and wiring diagram of Allen Bradley PLC input model programming technique. We explain a simple input switch, that is push button switch connected in L1, that is input module L1. The programming address of ladder programming is C in the right side of the PowerPoint. So I:2 I is equal to input. To is module slot name, that is rack name. 0 is module terminal. Module terminal. So the address of the push button input is I colon 2 dot 0. That is 0 bar 0. That is module terminal is 0 bar 0. 2 is module slot. Then I is input. The output model wiring diagram of Allen Bell. So output L1, L2, then O colon 4. O colon 4 means output. This output, this is input, this is output. The output devices, the output is connected to output devices like motor, solenoid, valve, lamp, buzzer. A basic simple wiring diagram for input and output. The input is L1, output is O colon 4. So the conductor, the output O colon 4 is conductor. This is for simple ladder program for input and output. Very simple program. When the input is high, the output is high. The input is low, output is low. Whenever you press switch, input switch, the output is high. That is the motor run or the lamp is broken. So we see a simple process, mixing of two liquids in a tank. Two solenoid valves are used for input valve A and B. A is some liquid or B is another liquid. Both liquids are mixed in the tank. The motor used for mixing the two liquids. The float switch is used for sense the tank level. The C is a output solenoid valve. So the C solenoid valve get the mixed liquid. The A and B connected to PLC input. The float switch also connected to input of the PLC. The motor and solenoid valve, that is output. The A and B is input of tank. The C is output of tank. The float switch is input. The motor is output. The A and B solenoid valves are also output of PLC. The solenoid valve controlled by the PLC. So the output of PLC is A, B and C. When the tank is low, the A liquid and B liquid mixed in the tank. So the valve is open. A and B valve is open. The timer, the PLC timer program operate A and B valve. Depend upon the programming timing, A valve and B valve is open. So the mixing of liquid in the tank is controlled by the timing of solenoid valve. The tank is filled, sensed by the float switch. The motor is off. The input solenoid valve is also closed. The C solenoid valve is open depend upon our requirement. So the PLC implementation